All right. What we've been studying, the fancy name for what we've been studying, they're called transformations. Transformations. When I say read, I'd like you to read with me. Ready? 1, 2, 3, read. What are rigid transformations? Put your hands like so. Ready? Make your circle bigger. Make your circle smaller. That was your first transformation. Tell the neighbor, what is this called? We did it right before break. Okay. Yes. Dilation was your first transformation. Transformation means to move on a coordinate plane. Now, there's a total of 4. Dilation is 1. Popcorn style. What are the other 3? Translation, rotation, and reflection. Okay. Dilation changes the size. Translation, reflection, rotation do not change the size. That's why we call those rigid. It means the shape stays the same. We're just going to move it around. We're going to slide it. We're going to flip it. We're going to rotate it. So right here, we're going to zoom through this and go through 2 examples. See that heart there? How many of you have made a Valentine's before? Like a paper one, like that. You see it? Everybody? Okay. See that pink heart right there? I'd like you to draw the line that would represent the fold mark. Draw the line that would represent the fold mark. Yeah, that's where it would be. Okay, so you fold and then you cut it out and then you end up with 2 equal shapes on either side. That is called line symmetry. A shape that can be folded across a line and it creates 2 congruent shapes. That's called line symmetry. To fold across a line and get 2 different shapes, or same shapes, excuse me. Ready? See that sun? Okay, I'd like you to draw a single line that would represent line symmetry on that sun. Go. A single line, just one. Just ask yourself, if you had a physical printout of this, where could you fold it so you end up with the exact same thing on both sides, just like a Valentine? All righty, guys. How many of you drew a vertical line right down the middle this way? Vertical line. Okay. How many of you went horizontal straight across? Okay, usually that's your. Ready? There's more. I'd like you to find all possible folding lines of symmetry. Go. Don't say it out loud. Don't count out loud so people can think. Find all possible. Do not say it out loud. Remember, it means to fold and get equal sides, equal items. Okay, with the show of fingers, I want you to tell me how many lines did you find? Everybody, show me with fingers. Show me with fingers. How many lines of symmetry did you find? Okay, look around at your neighbors. Okay, does anybody next to you have something different than what you're folding? Start arguing as to why. Okay, remember this day, guys, because the majority is not always right. The vast majority of you, with only about 3 people, said 4. There's 8. Oh. Ready? Start talking to each other. Why is there 8 there? Do you see the green if you fold on the green? Okay, that's called line symmetry. There's technically 8 there. You could fold on the pink and still get the same thing. Yeah, tricky. I know. There's only about 3 of you that got that one. Okay, then there's another kind of symmetry. It's called rotational symmetry. I'd like you to put a dot in the middle of the heart. Now imagine that's a hinge point, like someone stuck their finger and they're going to hold it there. Ready? I'd like you to put your pencil right here, and You're going to imagine, I want you to imagine rotating this Valentine. Rotate, start taking your pencil around, rotate that Valentine. I want you to stop your pencil when you get the exact original shape. So for that heart, if you rotate it to get the exact same shape, how many degrees do you have to turn? All the way around. Okay, that's called rotational symmetry. So write the word rotational and then cross it out because that heart does not show rotational symmetry. I'll explain why in a minute. So write the word rotational, then cross it out because the heart does not show rotational. Now, put a dot in the middle of the sun. Put your pencil right up there at the top flame. Okay, ready? Now, pretend you're rotating the sun and stop immediately when you get the exact same image. Shout stop when I get there. Aha. So most of you, all I do is a 1/8 turn, and I get the same image. This is rotational symmetry. Rotational, yes. And the reason why is you can rotate less than, underline less than. You can rotate less than 360, and you got the same shape. Okay, now we're going to go through our motions. This is a recap of the video, so I'm going to go kind of fast. I don't expect you to understand. We'll do 2 examples, then you'll understand. So don't freak out if you don't get it right now. Ready? The first one is translation. Put above the word translation, just write slide. All right, to slide. Now, when you slide horizontally, you slide vertically, or a combo of both. So just write the word H for horizontal and V for vertical. And when you slide a coordinate around, all you do is you add the horizontal component to the X. And you add the vertical component to the Y. We'll do one of these together. This won't make sense until we do it together, and that's okay. When you see my finger go like this, it's like choir director, it means join me. Okay. Pay attention. We go. 2 slide. Add to the left, add to the right. 2 slide. Add to the left, add to the right. 2 slide. Add to the left, add to the right. That's translation. Next one, we're going to reflect over the y-axis. So darken the y-axis. Put one arm up like a y-axis. Now put your hand here. Do this with me, please. Now, take your hand and flip over the y-axis. Flip it back. Keep it the same level. Flip over the y-axis. Flip it back. Now, question, the motion of your hand, is it horizontal or vertical?
Horizontal.
I'm making sure I don't give you your right face because I want you to be determined that you know. Some of you are changing your answer by my face, and I'm specifically going like no, yes, just to confuse the daylights out of you. Stick to your guns. Arm up. Ready? Watch. This hand is moving horizontally or vertically?
Horizontal.
There you go. Now, because it's horizontal, to flip over the y-axis, we opposite the x-coordinate. But Ms. White, it's the y-axis. No, to flip over the y, it's a horizontal motion. So to flip over the y, opposite the x. Flip over the y, opposite the x. To flip over the y, opposite the x. Now, arm horizontally, please. Follow. Come on, guys. Follow. That's horizontal. Now we're going to flip over the X. Take your hand, go over the X axis, go back again. The motion of your hand, horizontal or vertical? Vertical. So to flip over the X, you opposite the Y. To flip over the X, you opposite the Y. To flip over the S, you opposite the Y. Again, to flip over the X, you opposite the Y. Now this one, darken that point right there. That's going to represent the origin, which is 0, 0. Let's just take, it's easier to see this if you have 2 points. So do that point and find the matching point over here. Darken it. Put a little star or something. Now, connect those points, and you can see we're flipping right across the origin. Connect those points. But we're not just reflecting over the origin from one point to the other to sweep an arc. How many degrees is that? So you need to realize this. Reflecting over the origin, rotating 180, same thing. And we're just basically going from one quadrant to the other. So you keep X, Y, and you simply opposite the signs of both. To flip over the origin, opposite both. To flip over the origin, opposite both. To flip over the origin, opposite both. Okay. Last two are the tricky ones. They are rotating 90s. Rotating 90s clockwise and counterclockwise. To rotate 90 clockwise, everyone with your fingers, show me what direction is clockwise? Going to the right. Yeah, going to the right. Okay, so step one is to rotate 90 clockwise. First, you switch the order. Switch the order. Then, watch. Draw a clockwise arrow, and flip that sign only. That's why you draw a clockwise arrow. So it goes like so. To rotate 90 clockwise, switch and flip to the right. Say it with me. To rotate 90 clockwise, switch and flip to the right. To rotate 90 clockwise, switch and flip to the right. Last one. Okay, counterclockwise. Here's you first you switch. All right. Now we're going to draw a counterclockwise arrow, which is to the left. Flip that sign. So it goes like this. To rotate 90 counterclockwise, switch and flip to the left. To rotate 90 counterclockwise, switch and flip to the left. To rotate 90 counterclockwise, switch and flip to the left. Okay, we're going to do two problems together. Ready? I'd like you to go to problem number 5. Everybody go to 5, please. 5. I know for the, second page? I'm going to put it up on the screen. Sorry about that. We're ready, guys? You're looking here. I'd like you to read this, please. Read and fill in this blank. Go, quick. Look at this split. Read, fill in the blank. We're doing problem number 3, please. Problem 3. Did I say 5? I apologize. 3. Problem number 3, please. Sorry about that, guys. Yeah, everybody's on this one. Ready? Fill those blanks out. Quick. We're doing split. Now, say it out loud. To slide. Add to the left. Add to the right. Step 1. All I want you to do is get these coordinates. I need to know that you can accurately identify coordinates, because if you can't accurately identify these coordinates, everything else is kind of hopeless. Ready? Get me those coordinates, please. Go. Get me those coordinates, please. Those are, yeah, good. You're the first person to ask that clarifying question. Yes, those are singular units. Good job. If you don't remember how to find positions, ask your neighbor. Find those coordinates, please. Okay, check. Thumbs up if you got those coordinates right. Thumbs up? You good? No? Israel? All right, guys. Ready? Now it says we're going to translate fancy name for slide. We're just going to slide it around. Triangle RFY, 6 units to the left, 8 units up. So we add to the left, add to the right. So underline, please, 6 units to the left. Wait. Just relax. I know what you're thinking. Give me a second. Ready? Is that a horizontal or vertical motion? Left. Horizontal. It's a horizontal motion. Now, second question. Is left positive or negative? Negative. So technically, we're going to do -6 to all of these. So you do 5 -6, and you get your new coordinate. Okay? I would like you to do all those x coordinates. Take about 20 seconds and do those. Check. You got it? Okay. Next one. It says right here 8 units up. Is that vertical or horizontal? 8 units? That's vertical. Are we adding or subtracting? Adding. So for all of these, you're going to add 8. So -2 plus 8. There's your first coordinate. Ready? You do the rest. Start plotting those coordinates, please. Plot those coordinates. I know, it's one flies off. It's okay. Just plot it. Go up a one. Ready? Plot those coordinates, please. Plot those coordinates. Yes, one of them flies off the grid. You'll live. Just make a little dot there. I want to plot those coordinates, everybody, and label with sub R, sub F, and sub Y. Okay, close it up. Close it up. Ready? Check. If you've done this correctly, you should have the exact same image. It's just been slid, yes? Okay, ready? I want everybody to do this one thing with me. Put your pencil on R, please. Put your pencil on the original R. Ready? I'd like you to physically bunny hop 6 to the left. Go. Okay, ready? Now, turn a corner, go 8 up. Same thing. How do you like the bunny hopping? I'm more than happy. The reason why I showed you, because in computer programming, when we're doing motion in the coordinate plane, they can't physically bunny hop coordinates. They have to use the mathematics of it. Can you bunny hop? Yes. But warning on the test, if I don't give you a grid, you have to be able to do it both ways. All righty? Okay, we're going to do one more problem together. Everybody turn to problem 7, please. 7. I'd like you to read those instructions and fill out these blanks here. We're on 7. Fill out the blanks and fill out the coordinates, please. Fill out the blanks and fill out these coordinates. Yes, by 1. Thank you for asking. Fill out those blanks, fill out those coordinates. If you think you know what to do there, start working. Make sure you're on the right one, guys. I was just waiting for everybody to get ready. Check, look up here for the original. Now, never do both these steps at the same time. You switch and then flip. Which way are we going here? Clockwise or counterclockwise?
Clockwise.
Clockwise, which means we switch to the right. Let me show you. Step 1, just switch the order. So this is 5, -2. See what I did? 3, -4. 1, -3. I just switched. That's all I did. Just switch. Ready? Now we flip signs, but we're flipping signs to the right. Please draw this arrow. Ready? Draw a clockwise arrow. Flip that sign. Clockwise arrow, flip that sign. Clockwise arrow, flip that sign. Start graphing. And label your points R prime, F prime, and Y prime. Graph, guys. Graph those points. Graph all 3. I'm going to turn on the lights. Can you turn the lights, okay? Take a look. Now, some of you, it's kind of hard to see. Where does this 90 come from? Let me show you how to make sure you're correct. What's your favorite color? Blue, green, red. I heard red first, so I'm going to go there. So I'm going to work with the Y points. So everybody put your pencil on the origin. Now draw a line through the first Y point. Yes?
So when you switch like negative to the negative 2 to -5, it still stays -2?
Yes, because you're only flipping the sign on the right. Now draw a line through to the Y prime. Now look. Does that look like a right angle? It should. And are you going clockwise? Great. Okay, now you know what you're doing. Everybody, go back to the front of the packet, please. We're going to start with dilation, which is before vacation. Get those coordinates. And I'd like you to roll into your quads, please. Roll into your quads. Face each other. I'll be around to help you with dilation in about 2 minutes if you need help. Roll in your quads, guys. Starting with page 2, problem 1. Dilations. Dilations, you don't remember how to do it, call me over. Okay, so what's your first one? Yeah, around here, 2. 8, 6. Okay, so I want in the space between, I like to put 8 and the space between 6. 8, 7, 6. Right? What are we dilating by? Dilating by. Okay, ready? It's arrow in, arrow out. Now you could do 8 times 3, that's 24 divided by 2, that's 12. That's fine. Some of you can multiply straight off and realize that's 12. So it's easier to just do arrow in, arrow out. No. Okay, dilation, you need a refresher. Call me over. Okay, ready? Pay attention, guys. Roll around. Turn around. Okay, on your first coordinate, it's 8 6, right? Okay, I like you to write 8 in the space and 6 in the space between, put that real big. You got that space there? 8 6. Now, what are we dilating on? So, times 3 over 2 times 3 over 2. Ready? Arrow in. 2 goes into 8. How many times? 4. Bring it around, little baby 4 there. 4 times 3? 12. So your first coordinate is 12. Ready? 2 goes into 6. How many times? 3. Turn around and times 2 is 9. Okay, rapid points. You need help with dilation. Call me over. This team guys, if you finish the first one, fine? 3 over 2, no one at all? Okay, so do me a favor here, just talk me through how it, what's this? 8 times 3 over 2. Yeah, for sure. Okay, watch. I'm going to do this arrow in. 2 goes into 8, not, that's why I call it in. 2 goes into 8. How many times? 4. Excellent. 4 there. 4 times. There you go. Anybody need help with that dilation? That page is right up there, guys. Guys, page 3, I pulled it up. It's a little hard to see. Yeah, your numbers are right up there. Colin, you okay with dilation? You doing okay? Guys, page 3 is a little hard to read. I have it up on the screen. I say to go overhead, and then I date myself. The verb to date has something else besides like driving down to my house. I'm sorry, you can blame my English teacher, senior high English teacher. So you're actually going to look it up and take it to context.
Oh, now?
No, I used to, listen. I was about to use the term overhead versus screen. And I said, oh, I don't want to date myself. So I can look up a word and figure out what word I'm going to update. Yes, now. Actual. Yeah, guys, can you roll a little bit that way so people can get to the screen? James, when you're done with the page, go check. Yes, sir. No, it doesn't mean you flip. I didn't say opposite. Opposite. All you do is opposite. All of those are the opposite of signs.
Up to the present moment.
What's that?
Up to the present moment.
Okay, so Tuesday. Is there another? There should be another definition. And see, that's it. So to date something, like I would say, that's the word overhead. And you guys haven't seen those since we were in elementary school, right? Yeah, that's right. To date. Are these okay? Sure, and that's why how I would that's big. I don't remember grabbing it because it's still no, I don't you know what, maybe, let me check my dictionary. Okay, grab it in the dictionary.
Oh, you're right.
Oh,